Have you ever wondered what happens to the remnants of our ventures into space? Just as we leave footprints on the sands of time, we leave a trail of debris in the vast expanse of space. This debris, often referred to as space junk, is an unexpected byproduct of our ceaseless space exploration. Picture this: defunct satellites, spent rocket stages, fragments from disintegration, erosion, and even tiny flecks of paint, all orbiting our Earth at breakneck speeds. These fragments, no matter how small, pose significant dangers to both manned and unmanned space missions. Imagine a tiny bolt hurtling through space at thousands of kilometers per hour, colliding with a spacecraft. The potential for damage is immense. Over time, the accumulation of space junk has evolved from a minor concern into a significant hurdle. Space junk, an unexpected consequence of our journey into the cosmos, has become a modern-day dilemma. Our story begins in 1957 with the launch of the first artificial satellite, Sputnik. It was a monumental achievement, a testament to human ingenuity and the dawn of a new era. But along with this success came an unintended side effect: the birth of what we now know as space junk. Space junk, or space debris, is essentially any defunct, lost, or discarded object that remains in orbit around Earth. This includes everything from spent rocket stages to defunct satellites to even tiny flecks of paint. The genesis of space junk can be traced back to that historic launch of Sputnik. While the satellite itself re-entered our atmosphere and burned up, not all components of the mission met the same fate. The rocket body that propelled Sputnik into space became the first official piece of space junk, remaining in orbit until it too re-entered Earth's atmosphere about 2 months later. But that was just the beginning. As we continued to reach for the stars, the number of objects left behind in space began to multiply. Each launch, each satellite, each mission left its mark. For instance, in the mid-1960s, the United States launched a series of satellites known as the Transit Series. These satellites, used for navigation, were each accompanied by 4 solid rocket motors. Once their job was done, these motors were discarded, becoming yet another addition to the growing amount of space junk. Fast forward to the present day, and the amount of space debris has grown exponentially. Non-functional satellites, spent launch stages, even tools accidentally dropped by astronauts during spacewalks all contribute to this growing problem. It's a cosmic junkyard, a testament to our achievements, but also a stark reminder of the challenges we face as we continue to explore the final frontier. As our ambitions soared, so did the amount of debris we left behind in space. Our journey to the stars has been a tale of triumphs and trials, and space junk is a part of that narrative. As we look to the future, it's a challenge we must face head-on. It's not just the quantity of space junk that's worrisome, it's also the speed at which it travels. Yes, speed, in space, is a game-changer. Imagine a piece of debris as small as a marble, hurtling through the vacuum of space at speeds up to 17,500 miles per hour. That's fast enough to travel from New York to Los Angeles in less than 9 minutes. Now imagine that marble-sized object colliding with a multi-million-dollar satellite or a spacecraft with astronauts aboard. The result? Catastrophe. Such high-speed collisions can create even more debris, leading to a domino effect known as the Kessler syndrome. Named after NASA scientist Donald J. Kessler, this theory suggests that as the amount of space debris increases, so does the likelihood of collisions. Each collision in turn generates more debris, leading to more collisions. In essence, this could create a cascading chain reaction, making some orbits around Earth so cluttered with debris that they become unusable. Think about it. If the Kessler syndrome comes into full swing, it could potentially lock us on Earth. It would be like living in a house surrounded by a rapidly growing pile of broken glass. Every time you try to step out, you risk getting cut. It's the same with space debris. Every time a satellite or a spacecraft is launched, it risks colliding with this growing cloud of space junk. And it's not just about protecting expensive equipment or safeguarding astronauts, it's about protecting our link to the universe. Satellites play a crucial role in everything from weather forecasting and global communications to monitoring climate change and exploring the farthest reaches of our universe. Imagine a world without them. In a realm where even a tiny piece of debris can cause catastrophic damage, the growing cloud of space junk poses a significant threat. So as we gaze into the cosmos and dream of exploring distant galaxies, remember, The first step is cleaning up our own backyard, our very own orbit around Earth. Our future in space hinges on our ability to safely navigate through this sea of debris. This is not just a poetic metaphor, but a stark reality we face today. The impact of space junk on space exploration is profound and worrisome. Space debris poses a significant challenge for both current and future missions. The sheer number of these discarded objects orbiting Earth presents a literal minefield for spacecrafts. Each piece, no matter how small, is a potential missile due to their incredible speed. Even a fleck of paint can cause substantial damage when traveling at thousands of miles per hour. There have been instances where space junk has already caused problems. In 2009, an inactive Russian satellite collided with a functioning American one, creating a cloud of debris. In another instance, astronauts aboard the International Space Station had to take shelter in their Soyuz spacecraft due to a potential collision with space junk. These instances underline the severity of the issue. Future missions, especially those aiming for deep space exploration, could face even greater challenges. Manned missions to Mars, for example, will need to pass through the debris field twice, once while leaving Earth and again upon return. The risk of collision, therefore, increases exponentially. Moreover, the accumulation of space junk could potentially trigger a cascading effect known as the Kessler syndrome. This theory, proposed by NASA scientist Donald J. Kessler, suggests that as more debris is created through collisions, the likelihood of further collisions increases, thereby creating even more debris. If this were to occur, it could render space exploration and even the use of satellites untenable for generations. The space debris conundrum also raises ethical questions about our behavior in space. Should we continue to treat outer space as an infinite resource? Or should we adopt more sustainable practices? The answers to these questions will shape the future of space exploration. The path to the stars is now cluttered with the remnants of our past endeavors. The challenge is daunting, but it is one we must face if we are to continue our journey into the cosmos. But all is not lost. There are solutions on the horizon. Today, the scientific community worldwide is working diligently to tackle the space junk problem. A multitude of innovative solutions are being researched and developed, with a focus on removal and mitigation strategies. Firstly, various space agencies are exploring active debris removal. This involves launching missions to capture and deorbit large defunct satellites or rocket bodies. One such example is the eDeorbit mission by the European Space Agency, aiming to use a robotic arm or a net to capture space debris and safely guide it back to Earth. Another approach is the use of laser brooms. These are ground-based lasers that heat one side of a piece of debris, creating a thrust that can alter its orbit and eventually cause it to re-enter the Earth's atmosphere and burn up. On the mitigation side, we see a strong push towards making space missions more sustainable. This includes designing satellites to have a shorter lifespan, after which they can be deorbited and burn up in the Earth's atmosphere, thereby not adding to the existing pile of space junk. Another important mitigation strategy is implementing stricter regulations for satellite launches. This means ensuring that every new satellite launched has a plan for its end of life, whether that's to deorbit and burn up, or move to a graveyard orbit where it won't pose a threat to operational satellites. Moreover, there is a growing emphasis on space traffic management. Just like air traffic on Earth, we need to have a system in place to monitor and manage the orbits of all active satellites to prevent collisions and further creation of space debris. While these solutions show promise, it's clear that there's no silver bullet to the space junk problem. Sustainable practices in space exploration will be key moving forward. As we move forward, we must balance our desire to explore with our responsibility to preserve the cosmos for future generations. So, what have we learned about space junk and its impact on space exploration? Let's take a moment to reflect. We've uncovered the enigma of space junk, a term that refers to the defunct human-made objects scattered in space. We traced its genesis back to the launch of our first satellite, Sputnik, and how the problem has only escalated since then. We've also delved into understanding the growing threat it poses, not just to our satellites, but also to the safety of astronauts and the International Space Station. The impact on space exploration is significant, posing severe challenges to our future ventures into the cosmos. However, we didn't stop at highlighting the problem. We ventured into the future, looking at potential solutions like space sweeper satellites and deorbiting mechanisms. It's clear that dealing with space junk will require a combination of innovative technology and international cooperation. The cosmos is our final frontier, and it's up to us to ensure it remains open for exploration, unmarred by the debris of our past.